This is yes, a presentation on how to run LLMs on device. As Isham said, I'm an independent software engineer, and I've been I was curious basically to see if this was possible, and this is the result of a bit of investigation that I have done. Okay, so let's begin. So these are the main topics. So basically, why would you want to do that? Why would you want to run an LLM on an edge device? What are the opportunities? What are the challenges that are stopping us from doing it at scale? Then I chose summarization as an example task for which an LLM is a good candidate. Then I will show you a hands-on demo on my phone. I will share the screen of my phone and you will be able to see it. And then I will try to imagine what possible future developments there could be on this area. If you have questions, if you want to ask something, or if I'm not clear, just say so. Don't worry. Just interrupt me and say so. Thank you. So, as I said, why should we even want to do this, considering that it is going to transform our device in hand warmer and it is going to kill our battery? Well, there are a few reasons. As I said, get a digest of your emails. I receive a lot of emails, and many of them are useless, but they still take space on my inbox, and you never know, maybe there is something of value there, but looking through all of them is a bit of a pain. And yes, you could use ChatGPT to do that, but would you really want to send your emails to ChatGPT to get a digest? I think someone might be a bit worried about that. Then there is the possibility to, of course, actually chat with your data, where model on your phone has access to your data, and so you can say something like, show me all the PDF documents in this device from the last week that talk about a particular subject, for example. And then there is a use case that is especially valuable for example, people of determination, the ability to use an application to help them see their environment, understand their environment better, even when there is no connectivity. There are others, of course, but these are the ones that came to mind. So yeah, so now, why can't we do this? Well, there are device constraints, meaning that even the most powerful mobile phones are not powerful enough to use this in a reliable way, and you will see this later on with the hands-on demonstration, because I have an S24 Ultra, and as you will see, Llama 3 struggles to run on my device. So you can imagine how it would work on a device with lesser resources. Then there is the model size. So even if the mobile phone was super powerful, all these models require you to download gigabytes of data, which is possible, but it's a bit of a friction. It doesn't make the thing easy to use, easy to leverage. And last but not least, yes, the frameworks that allows you to run inference or to train a model on a device, they're still in their infancy. One of them is MLC LLM, another one is Executorch, but they are both not considered ready for a general audience. More often you have to compile them from source, you have to hope that they work. Just to give you an example, I tried to follow instructions on how to run Executorch on my machine. I was following the tutorial and the tutorial failed because apparently there is a missing file in the GitHub repository. So, yeah. But there are also opportunities because we can imagine that the phone hardware will continue to evolve. There are models being developed that are especially suited for edge devices. For example, yes, mobile llama is an example, but there are others. And these frameworks that allow you to run these models locally, they're being actively developed. So you could say it is a matter of time before we get something that is ready for the general audience. So now, as I said, I wanted to use summarization as an example task. And let me explain why very quickly. So, as you probably know, summarization is a specific NLP problem, which means that there are specific models for summarization. So, why wouldn't you use those instead of relying on a full-fledged LLM? Well, to me, and I hope to show you with as I continue this presentation, summarizing a text often requires reasoning because you need to understand what the author wanted to say. And reasoning is something that LLMs are good at, but simpler transformers architectures, such as summarization model, might not be. So this is the article that I chose. It is, as you will see, it is a long article from Foreign Affairs, which is a magazine known for having long articles. And it has an underlying message that it's important to get, and we will see that not all the models can get it in a way that is satisfactory. So I hope that the QR code works. I tested it and it works. If it doesn't, just let me know, and or maybe, or if you want me to drop the link in the chat so that you can click on it. So, as I said, first, we will try to use simple transformers from Hugging Face. So these are the transformers that I used from Hugging Face just because they were the highest rated models for summarization. So the first thing is that simple transformers, they have a very short context window. As you can see, BART large CNN, which is the first model, and the Google Pegasus Daily Mail, which are two transformers, they have a context window of 512 and 124 tokens. which is very short. I mean, if I have 1024 tokens of an article that I want to summarize, I might as well just read it because it is going to be quite short. Then there are another, you could say, another class of these transformers that are based on the Google T5. And these are interesting because these don't have token constraint. As you can see, Falcon AI, Flan T5 base, and Google T5 large, they're all based on Google T5, and they managed to generate something. The problem is that, for example, Falcon AI invented a character that is not there. Eric Liu is not mentioned in the article. Google T5 invented this Julian Zelizer, okay, and Google T5 also put some, Flan T5 just put some random characters that made not necessarily sense. And the sentence generated by Google T5 large is not a proper sentence because it ends in apolarizing ... So it is not really a sentence. So now let's see what Llama has done. Llama 3, to be precise. So again, this summary is a bit long, so I put it in a gist, and I put the text, and I will just open it to read it with you. So in this article, it doesn't mention how many seats were won by the Labour Party at the last election, which is what all the other transformers mentioned and focused about. And it is trying to capture the larger, if you wish, the more nuanced message, which is that the UK has issues that relates to Brexit, that there are problems related to the way in which the UK is governed, and the need to change the way of government. So if you compare this article with the summary that was generated before by these transformers, I will just go down. Just a question, do you want me to read it, or can you read it from the link? Hello?
If you're sharing the gist on GitHub, I don't think we're seeing it. We're still seeing the slides.
Yes, because I put the link. Do you want me to share the gist? Okay, I will share the gist. Just a second.
Can you please share it here?
Sure. So let me increase the font. Sorry. Is it readable? Do you want me to increase more?
Would you share the link in the chat, please?
Sure.
I've shared it. You can continue.
Sorry. Yeah, you were faster than me. Sorry. Okay. So I will just give you a few moments to read it.
So now the edge device will summarize this article, right?
Sorry?
The edge device will summarize this article, right?
No, because it would explode.
Okay.
Unfortunately, I'm just going to show summarization of something that is much shorter because I tried and it doesn't work. The only thing that I wanted to show is that LLMs can do a much better job at the summarization compared with the models that are specifically made for the summarization task, basically.
Got it.
Okay. So now I will show how this thing works on a device. I've used an Android application that actually is freely available. It's called MLC LLM, and it is available, I think, on the Play Store. And I slightly modified it to make it more integrated with Android. And I'm going to show you. Sorry. So you should be seeing my phone. This is GitHub repository for a library, but we can open anything. So, for example, so I am selecting. And then here, this is the modification I did to the app to add this summarize button to the context menu. And now we wait, basically, because this is not. So as you can see, it created this prompt, which is basically, please summarize this article, and then it just pasted the text that I copied. Oh, sorry. And now it's building the summary. So as you can see, it took quite some time. I think this can be improved by using by doing something which is not in real time. So one way to make this work better would probably be to schedule summarization job, or in general any kind of text generation job using background tasks, and just providing the user with what's it called, progress bar, which would show like when the task is ready. But yes, this is to give you an idea of the speed. Sorry, I just saw your question. When can we ask question? You can ask question anytime. I said it at the beginning. Maybe it was not clear. I'm sorry. So
yeah, can I ask a question? Sorry, guys, jumping in.
sure, please.
Yeah, sorry, I think I missed the first part of the presentation. Just like Mr. Mahdi has asked here, I had the same question: how much resources it consumes? Is there any test on? I mean, how much battery it consumes? I mean, how long you can keep this running? I mean, what's the size of the model? If I missed the model size in the beginning, can you answer that?
So the model size, I think it is. I can check, but it is Llama 3. This is Llama 3.
Okay, it's Llama 3, but it won't be the full thing, right? I mean, it must be a condensed
the
version.
full thing. It is the full thing.
The full thing on the phone.
Yes. So let me show you, because this is.
I mean, because it's surprising if it's the full thing, because it may consume a lot of battery, a lot of.
This is Llama 3, 8 billion.
Mm-hmm.
So this is the app, MLC chat. This is the app. If you download this app from the store.
Okay, so it's a quantized version, right?
Yes.
Okay. Yeah, I was curious about that. Yeah. Okay.
And you can download other models.
So there are any benchmarks, like how much I mean CPU, let's say RAM or whatever it consumes, how long we can keep it running? It's quite a big model, right? As far as I see. How many MBs or GBs is this?
Excuse me?
I mean, what's the size on the disk when you download all of this?
I think the size on the disk is a few gigabytes. I need to check, because unfortunately the app is downloaded. I haven't tried to package the model with the app, although it's possible.
Yeah, that's, I mean, anything. I mean, I ask this question
So
because I understand that when we put these models on the phones,
yes,
we as users, end user, definitely would not like to like such models to choke our phones, right? So
yeah,
these are quite.
that's what I said at the beginning. That one of the challenges is that these models are big. So just to give you an example, there is a model called Mobile Llama, which is an optimized llama, which is, I think it's cut down to 1.5 billion parameters. But if you were to download the file, it is still 5 gigabytes.
Wow, that's quite big.
And it is an optimized model. Let me show you. Just a second. Hugging Face. So let me show you the screen, because you're not seeing the screen, just because I wanted to find it first. Here. Here. And present the calculator. Okay. So this is the Hugging Face repository for this mobile llama, 1.4 billion. And as you can see, PyTorch underscore model.bin, it is still 5.46 gigabytes.
Okay.
And there is another problem which I forgot to mention, and that is that, I mean, I explained that these frameworks that allow you to run the models on the device, they are in their infancy, and it is true. There is also another problem, that the model need to be converted. So, for example, I haven't found a way to run Mobile Llama on a mobile device, because when I tried to run it through Executorch or MLC LLM, they didn't support this architecture. They supported the standard Llama architecture, but not this cut down version. And the instructions to do so are a bit sparse. So yes, this is definitely another problem that you have. But just to show you how much this thing is not ready for to be used, like let me try to summarize something longer on my device. I just need to find it. Just give me a second.
Yeah, go ahead. I also have one question. Maybe you can
No,
answer
please,
later.
please.
I was more curious, like how things would be going under the hood, right? Like if there's any custom model, let's say any custom model you build, Enrico builds us a model and ships it to us, and how are we going to supposed to load it on our phones? Is there any standard way of doing it, or everybody is, like it's out in the wild, everybody's for himself, and we need to manually do a lot of stuff ourselves? Is there any framework? Because I understand, like, for example, if you're going to load a model in for example, Android, it's probably some sort of a wrapper that's written around these models, these PyTorch models, right? They sit on your device and somehow they get inferenced. I don't know how it works. I have no idea. So that's why I'm asking this question.
If you look at the tutorials, basically what they say, for example, when you want to support or when you convert a new model so that it can be used by MLC LLM, what they suggest is to upload the model on Hugging Face. But that means that either your user will have to download, in this case, 5.46 gigabytes from Hugging Face, or it will have to download a 5.46 gigabytes app from the Play Store. So this is why I said that the model size is going to be an issue, because even if you had a blazing fast device, it would still be problematic to download this type of models, especially if every app has its own model. Because imagine that you have an app with a model for, I don't know, for talking to your data. And then you have another app that has a model for, I don't know, image segmentation, and then you have another app for something else, this thing can add up quite quickly. If I may ask, so just for me to make sure that this point that I made on the slides is clear.
Superman.
Sure. Please.
Yeah, go ahead. I guess there was some noise from a mic.
Okay. I thought it was a question. Sorry. Yeah. So what I wanted to say is that I hope that this little demonstration show that yes, LLMs are better at summarizing than a normal summarization model. And now to show you just how this thing is not ready, I'm going to summarize the feature article on Wikipedia. Not because I think it is particularly useful, just because it is the first thing. So let me share my screen again with my device. So this is today featured article from Wikipedia, and it is not even the full article. And I'm pretty sure that the application is going to die, but let's see.
Also, is there a way for us to know how much RAM it uses?
No, it was faster than I thought. No, to be honest, I don't know. I need to do more checks, because the problem I think is that even if I check and see how much memory uses, how much it drains the battery, I don't think you would really be using this type of model, because this type of model is too heavy, I think, to be run on a device. Oh, incredibly, it works. So yeah, it is. I'm amazed because I mean, it's a bit non-deterministic, which is another reason why it is not really ready. Because sometimes the application just dies. Although I think it is because this application is trying to generate the summary in real time. So probably Android is complaining because too much stuff is going on the UI thread. And maybe sometimes it kills the presentation. Someone is asking which phone I'm using. This is an S24 Ultra. So yes. Okay, at this point we can try to be, I don't know. Let me try to, I can try to, no, it's okay. Okay, but so, are there any other questions, or may I go back to the slides just to finish, and then you can ask me more questions?
You're good unless you want me to run a poll.
Sorry?
You're good unless you want me to run a poll or something.
To run?
A poll, a voting system.
It's okay. I will try to. I will consider silence as confirmation that I can go back to the slides. Okay. So, okay. So, yeah. So, because some people raised these questions, I just wanted to discuss a bit the future developments, because I think that will answer a bit of your questions. Of course, I don't know what the future developments would be, but this is just my, how I see, basically, and take it with a lot of salt. So I think that to solve the issues that are inherent to LLMs, which is the size mainly, and of course the resources, these phones will come with a bundled LLM. So I don't know, Samsung will provide an LLM, Apple will provide an LLM. And then what they will do, they will provide an API to this model in the same way that you can access the various hardware of the phone using APIs. I think you will probably be able to access this model for inference in a way that is unified. Another development that I haven't put here because I found out about it this morning is that the latest Intel processors, they have a thing called an NPU, Neural Processing Unit, which is supposed to help with running inference. Now, I think this is interesting if it works. Unfortunately, I haven't been able to validate that it works, because normally we're used to think that to run inference in a way that is fast, reasonably fast, we need a discrete GPU. And this raises all sorts of issues, because you either need a desktop PC, which by definition is not portable, or you need a heavy laptop, which is more portable, but still a bit heavy. But with these NPUs, I have a laptop, which is a ThinkPad, which weighs less than 1 kg. No, sorry, 1 kg and 10 grams. And it has an NPU. So I was really interested in trying to see if this thing would work, because it would mean, I wanted to see, for example, if I could run Llama 3 in a way that is satisfactory, because as you can imagine, without a discrete GPU, just relying on the CPU, Llama 3 is excruciatingly slow. But I haven't been able to do that because, as I've mentioned before, all these things are very, very new and very, very cutting edge. So I was just following a tutorial on how to run an example, and it didn't work because probably I need to compile the library needed from source, which is usually the indication that this stuff is not really ready to be used by a wider audience, I think. So yes, so of course now you can ask me all the questions that you want. You can contact me on LinkedIn. You can ask me questions there if something comes to mind later. This is what I have, and now you can ask me more questions.
Yeah, as far as I know, the S24 has an AI accelerator chip. Does it work with this model, or it's just the normal CPU power?
So MLC LLM leverages the GPU. Of that, I am sure. Because apparently the Unity engine has a way to leverage GPUs on phones also for inference. So definitely it uses GPUs. I don't know if it uses this particular AI feature of the S24, but my gut feeling is that it doesn't, in the same way that Olama, for example, doesn't leverage NPUs. And that is because these things, they're not yet so widespread that they are supported.
I put a voting the poll system in the comments, so to give a feedback from how it went. Sorry for not taking your permission first.
It's okay. Don't worry.
Okay, there seems to be a user who missed a couple of points. Please ask your question in the comments or via voice chat.
I think there will be no more questions, but if you have later on, then please feel to reach out. Thank you, Enrico, for the insightful workshop.
Yeah, so sorry for interrupting you, Isham. I just wanted to reiterate, just feel free to connect. I am currently trying to work as freelancer, so please let's connect. And if you have, as I said, if you have any questions, just send them to me. And if you follow me, I will try to have this NPU thing work on my laptop, and I will keep you posted if the performance with Olama, for example, just with Llama 3 is better than just using the normal general purpose CPU.
Thank you. By the way, are these models like turned into low-level C code and compiled, or are they just running a Python rudiment?
I don't really think they are running in Python. Because I know that even NumPy is not pure Python, as far as I can remember. I think it has C binding somewhere. But I don't think any of this is running on pure Python, just because you need to have lower level access, and but even for things that we take for granted, like for example, instantiating a thread in Java, for example, or making a system call. You always go down to the OS level and you go down to a lower level language. So
Okay, I'm asking this because I had a previous experience of using a translator, like OpenAPI speech, something. And somebody told me, like Isham told me to use a C++ version instead of a normal Python version. And that should make a difference. So that's why.
I don't know, to be honest.
Like even the whatchamacallit, the llama model runner,
Yes.
it installs and it's not Python. Like
Oh, if you see the Android application, if you read the instructions, you will see that it will install some native libraries, and those libraries are basically JNI. So, sorry, Java Native Interface, which is a way for to call native code from Java. So I'm pretty sure that even the bindings that you call from Python, they go to a lower level.
thing. So there's like, we have to wait for new devices or find a smaller model that we can run.
Yeah, but as I said before, there is also another problem that when you find a smaller model, you need to tell Executorch or MLC LLM how to use them. Because as I was saying before, if you try to just run mobile llama on MLC LLM, it will not work because MLC LLM at the moment does not support the architecture of mobile llama and or another mobile model that is not llama but is optimized for mobile. So, and unfortunately, the instructions on how to do so, as I said, are pretty sparse. The MLC LLM page, I think, references a Colab notebook with an example. But the problem is that it is a bit difficult for someone to do this type of conversion or to extend MLC LLM to handle this new architecture unless you know that architecture really well, which means that probably only people that are very familiar with the models, either because they created the model or they work on the team that created the model, can effectively extend Executorch or mobile LLM, MLC LLM to incorporate these new models, these mobile-friendly models.
Thanks.
You're welcome. So as Gaura was saying, yes, so MLC LLM, they also have a web LLM. It is another experiment that they are doing to run an LLM on a browser. I just wanted to try the Android version because I thought that maybe it could leverage the phone a bit better. But yes, I definitely could try also the web LLM. Sorry, the web LLM bindings to run it off a browser. Okay. Thank you for your time. As I said before, sorry, can you please repeat the name of the web LLM? Well, MLC LLM. Let me just share my screen because maybe I should have put this in the slides, but this is my first presentation, so I guess live and learn. Okay, let me just, so let's go here, for example. So there is this MLC LLM, and this is the repository of MLC LLM. And as you can see here, it says that there is a web browser. And yes, you use web GPU and then WebAssembly, basically. So here you can find some information. This is the other. This is the proper website, LLM-MLC.ai. But if you look for MLC LLM on Google, you will find this. And yes, here, for example, there are instructions on if you want to use the WebAssembly and web GPU builds. And just to show you what I mean about documentation being sparse, if you want to integrate a new model architecture, it is just this link. And yes, it is showing there are a few PRs that show you how they integrated these models, which is great. But my point is that you need to be deeply familiar with the model that you want to integrate to present a PR and to ask for your new architecture to be integrated in MLC LLM. That's why I think in the end there will be some form of APIs that allows developers to just use the model from to do inference, the model that is just included in the phone, without having to worry about asking people to download 5 gigabytes or more for a model, and then using a lot of battery power. So yes, should I put this link in the chat? I don't know. Yeah, let me put it in case someone wants it.
Now that you mentioned this, I remember there is a Chrome developer article about Chrome built-in LLMs.
Ah, yes, the nano one. Yes. The nano model. But it was quite fast, but it was hallucinating a lot. But yeah, there is not much choice, because to make it fast, you need to reduce the number of parameters. But if you reduce the number of parameters, the possibility of the model spitting out garbage is pretty high. Okay. So let me see if I missed. Did I miss other questions? Okay. Okay, I will keep you posted if I manage to have something working with this NPU. As I said, I'm quite excited by the idea of this thing working, because it would mean that you can have a light, very light laptop, actually, and still be able to run a model locally with decent performance. So yeah, I will let you know how it goes. Unfortunately, I tried to make it work. As I said, I tried to make it work this for this presentation, because if you look at this NPU library, there is an example which is literally running Llama on the NPU. So I thought, okay, how hard can it be? And turns out that it can be quite hard, because it seems that you need to build the library from source. I thought that there was a binary distribution that I just could install with pip, but unfortunately, no. I will show you just this one last thing, just so you can see what I'm talking about. So this is the NPU library GitHub. So this is a library which is open sourced by Intel. Interestingly enough, this is under the Apache 2.0 license. And here you can see that this is basically something that is supposed to leverage this Intel neural processing unit, which is available on the latest Ultra Core processor, Ultra 7, Ultra 9 or something. It's just that here it says for the setup, it says that you can just install this package and use it. But I mean, from what I try to do, it just doesn't work. Okay, I think I talked too much, so sorry about that. Yeah, let's keep in touch. Thank you again. Bye.
Thank you, guys. Thank you. So if you guys have any suggestions for the future workshops, do let us know. And accordingly, we'll prepare. Cheers, guys. Take care. Bye-bye.
Bye-bye.